Today we're going to talk about 6-9, logarithms with other bases. For the warm-up, I'd like you to take a couple minutes and quickly do 1 through 5 and pause the video. I'm going to continue. If you let this run, you'll see the answers. So 10 to the first we know is 10. 10 to the second we know is 100. Using what you know about exponents, find x so that 10 to the x equals 50. Now, if you do this on your calculator and you play around with it, you're going to get an approximate number, 1.69. However, if you think about using logarithms, the way to do this problem, since it has a base of 10, you can write it as log of 50, which will give you a little bit more of an exact answer of 1.69897. E to the first is 2.718. That was a transcendental number from chapter 1. This chapter we will talk more about e as we go. E to the negative first, if you type that in your calculator, remember there's an e button and it's located by the pi, 0.3679. Alright, let's talk about converting between logarithmic and exponential equations. We want to be thinking about logarithms and exponential as inverses of one another. So in logarithmic form, if we have log base b of y, what we would write is the log base b of y is equal to x. In exponential form, it would be b to the x equals y. The common logarithm has a base of 10, so the common logarithm is really written log y equals x. And again, don't get too caught up in the variables. I'm using x and y's so you can see the placement, but we really could have any variables or any numbers. But when you see log of y equals x, what you have to understand is there's no base written. It's really log base 10 of y equals x. We call this the common logarithm. Years ago, the only way to find logarithms, I mean way back before even I was born, was through tables, and all the tables were written in base 10. Now the natural logarithm has a base of e, so the natural logarithm is going to be written ln of a equals b. That is basically saying the log with a base of e of a is equal to some number b. Let's try some problems. The key to understanding how to do this is to rewrite back and forth exponential to logarithmic form to exponential form. So see if you can take the notes above, pause the video, and see if you can do a and b for both sections here. Okay, log base 5 of 25 equals 2. If I was rewriting this to make it make sense in exponential form, we would say 5 to the second equals 25. Part B, we'd write 9 to the third equals 729. So those two equations are equivalent, whether it's in exponential form or logarithmic form. In the second section, rewrite the following in logarithmic form. We would say the base is 15. So we're going to write the base with the log. We're going to take the argument, which is 225, and we're going to write it on the left side. And we're going to say that's equal to where the exponent was. Part B, 2 to the fourth equals 16. Again, the base is 2. So we like log base 2 of 16 equals 4. And a good way to remember how to, when you're doing these, is like, it wouldn't make sense to write log base 2 of 4 equals 16, because why would you rewrite the same thing that you have in the original exponential form and just add a log to it? That doesn't really make any sense. So it's a good idea to know that you have to switch some numbers around on the left and right side of the equal sign. So let's try evaluating these. Now we want to do these without a calculator. Now my first suggestion, even though this is just a numeric expression, I would suggest putting in an x.
I can learn to understand you much better if I can get familiar with the way you talk.
Sorry about that. Log base 4 of 64 equals x. So then set it up using exponentials. 4 to the x equals 64. So 4 to what power is 64? The answer is 3. Part B. Again, set it up with exponentials. 81 to the x equals 9. So I just get used to throwing in a variable, even though it's not an equation. And I'm not going to write x equals because technically there's no x in the original problem. But I use it to help set it up and kind of clear my mind. So 81 to what power is 9? This is where the first part of our chapter comes in. We have to know that 81 to the 1/2 is basically the square root of 81. And that's what would yield an answer of 9. The log of 1/2 of 32. So again, rewrite 1/2 to the x power. Make sure you put it in parentheses if you're using this notation, equals 32. Well, we know 2 to the 5th equals 32, but we need the 2 to kind of be the reciprocal. So we can just simply say -5 would be our answer. And finally, 3 to the x equals 1 over 27. We know that 3 to the 3rd equals 27, but we need it to, again, be the reciprocal of that, so we can say -3. Special cases. Log base 7 of 7. See if you can do this without actually rewriting it. And just think to yourself, 7 to what power is 7? 1. 6 to what power is 1? 0. Natural log of e. Well, remember, that's log base e of e. So that'd just be 1. Find the base. So in problem number 1, rewrite it. X to the -4th equals 16. So if you think about what power here, so x would have to be 1/2. X to the 3rd equals 1/8 on number 2. So x would have to be 1/2. So two different scenarios where x is 1/2, but different looks with negatives, etc. Number 3, x to the 2nd equals 0. That is not possible, so we would say that this has no solution. Or we could say x is undefined. Next set, find the logarithm x. So we're saying 1/2 to the x equals 8. So that would have to be x equals -3. Over here, 1 to the x equals 3. Again, that would be undefined. X is undefined. So we'd say no solution. Think about it. 1 to any power is going to be 1. Next problem is to find the argument x. 3 to the 2nd equals x. So x equals 9. Number 7, 2 to the -5th equals x. So x equals 1 over 32. Explanations. Again, pause the video as you're doing this and think about what are the answers. How would you answer these questions? Can the log base 1 of 5 work? Why or why not? No. 1 to the x equals 5 is impossible. Can log base 0 of 5 work? No. Again, 0 to the x cannot equal 5. How about number 10? Can log base a of b, where a is a positive integer and b is a negative integer, work? Why or why not? No. B has to be greater than 0. That's the way it's defined. The definition of a log. Can a base b, where a is a negative integer and b is a positive integer, work? Why or why not? No. Again, definition. A must be greater than 0. And then the last two problems are solving problems. The natural log of the argument of 2x minus 3 equals 21. We would rewrite that e to the 21st equals 2x minus 3. We could solve that by adding 3 and dividing by 2. Now, if we were not using a calculator, that would have to be our final answer. If we were using a calculator, our final answer would be 6.59 times 10 to the 8th. Number 13. 2 ln x plus 2 equals 1. First thing we would do is subtract 2. We get negative 1. And then we would divide by 2. And then we would rewrite e to the negative 1/2 equals x. If we didn't have a calculator, that would be our answer. If we did have a calculator, we could estimate this to be 0.607. Good luck with your homework, ladies and gentlemen.